Alright, so this is the problem that we were doing in class on Friday, and I just wanted to kind of go over this again. So this was the diagram that we sketched, and we were talking about what the figure would look like, but this is actually, we rotated it about the y-axis, what it would look like. And then I just want to point out that this distance from like here to here, and from here to here, this is 1 and this is 1. So it has a solid where there's not a gap that has a height of 1, and then our gap starts, but that also has a height of 1. So that's important to note. So basically, this whole bottom part is a cylinder, right? This entire bottom is a cylinder. And this part is like a cylinder, except it has a hole in it. So if you remember from geometry, we had shapes that looked something like this. These were called, this is an annulus, okay, in plural annuli. So basically the annulus, to find the area, we subtracted the large radius from the small radius, right? So the large radius is the radius that goes the entire way through, and then the small radius, so this would be big R, and then the small radius was the radius that just went from the center to the inside. So the radius of the large circle minus the radius of the small circle. Well, what you're going to notice is that if we were to slice this into discs like we talked about, what's going to be happening is that our radius is going to actually be changing with every slice, because our radius starts out, or our annulus starts out with a smaller hole here at the bottom, and then as it increases, so this would more be like one of the bottom slices, this would be more toward the middle, and then as it reaches the top, right, the difference between the large radius and the small radius is it's a lot smaller of a change, right? So this might be in the middle, but then we might have one toward the top. Okay, see, this is why I was using tools to do this, because it just looks bad, but you get the idea. It looks more like this, where there's more empty space in the center. So the idea of doing this, we do it in two parts for this reason, that this doesn't have a hole in it as we rotate it around, but the top does. So I'm going to go ahead and I'm going to write the integral for the very bottom part. So from 0 to 1, where there's not a hole, we know that we're using the same equation and the same boundary, right? And it's still a radius. So basically, since there's no hole, our radius is 1, right? So x equals 1. But if we wanted to, do it like an annulus, well, the radius of our large circle, that would be this whole base, is 1. And the radius of our small circle, which doesn't exist, is 0. So when we were talking about it in class on Monday or Friday, we ended up doing something that looked like this. This is the large radius, okay, the entire width of, or the entire half of our circle, that would be from here to here, and then this is our small radius. So that's how they were getting 1 squared minus 0 squared, but you don't even need to think about it that complexly. It just has a radius of 1, because there's nothing being cut out. So that's how we got that part. And then our second integral, so that's half of it, so we're going to add to that our second integral, and we went from 0 to 1, because we're looking at y, and then we're going to go from 1 to 2. Alright, so the problem is, if we were going to be looking at slices, our rectangle would be drawn sideways like this, right? So basically we're looking at this being our dy, that's our height, okay? And then what's happening is our large circle still is x squared plus 1. Let me rephrase. Our large circle, which is this part right here, all the way across up here, that still has a radius of 1. So that's our large radius. We're going to substitute 1 squared. But from that, we have to take away the small radius. Well, the radius of this part is modeled from this equation, y equals x squared plus 1. So that's what we need to substitute in for little r, but since we're revolving around the y-axis, we need to solve we need to solve this in terms of y. So that means get x or x squared on one side and y on the other. So if I do this, I'm just going to subtract 1 to get x squared, because remember, we're always squaring x in both of these. That's why it's 1 squared, right? X squared equals 1 squared. X squared equals 0 squared. So that's how I put those in. So now I have x squared equals y minus 1. Well, it's already squared, so I can just substitute y minus 1 in. Okay, and this whole thing is a dy, okay, times dy. Because dy represents, in this case, the changing height of our rectangle. So I'm just going to rewrite this and then simplify it so that this is kind of nice and neat for me to integrate. So 1 squared minus 0 squared is 1 dy plus, from pi from 1 to 2. So I end up with, really, I'm going to write underneath 1 minus y plus 1. And remember, this negative carries to each term in my binomial. That's why I end up with a negative 1, a plus 1. So that means 1 plus 1 is 2 minus y dy. Alright, so that makes it a little cleaner to integrate. Alright, so let's go ahead and integrate. So pi times the integral of 1, and remember we're using with respect to y here, so it's y from 0 to 1 plus pi, and we could have factored out pi and just left that out front if we wanted to. The integral of 2 is 2y minus half y squared from 1 to 2, okay? And now we can go ahead and substitute. So in this one, normally I would substitute 1 and then subtract from that my substitution of 0 when I plug this in, but this has a single term in its y, so that means it's essentially 1 pi minus 0 pi. Okay, so if you didn't want to subtract 0 out, you don't have to because it keeps the same. Okay, plus, I'm going to go ahead and put 2 in here, so I end up with 4, and I'm going to leave pi out front for now. So I end up with 4 minus 2 squared is 4, divided by 2 is 2, so minus 2. Okay, minus, no, I'm plugging 1 in. 2 times 1 is 2. Negative half times 1 squared is minus half. Okay, alright, so now I can go ahead and simplify. So I end up with 1 pi plus, and it's giving me a hard time, pi times, what do we end up with? 4 minus 2 is 2, minus, we have 2 minus half is 1.5. Okay, so we end up with pi plus 0.5 pi. So our volume for this is 1.5 pi. So this is the volume of our solid.